Okay. Now that you have all settled, we can get going. So good afternoon, gentlemen and ladies. On behalf of the organizers, Professor Amol Dighe, Professor Rajdeep Sen Sharma, and myself, Indranil Majumdar, I welcome you all to this function. Those of you who have assembled here in person and also those who are there on Zoom. It's a distinct pleasure to do so. As you all know that we have all assembled here to felicitate our long friend and colleague, Professor Sunil Gupta. Professor Gupta assumed charge as President Designate of International Union of Pure and Applied Physics, IUPAP, from 1st January 2025 this year. He is the second Indian scientist to have been elected for this position. So TIFR has a long association with IUPAP, and several of our present and past colleagues have served in different capacities in the IUPAP, either as members or commission chairs, etc. It is most gratifying that most of our friends and colleagues of Sunil and of those who are associated and were associated with TIFR to readily agree to join this function either in person or on Zoom. We are extremely thankful to them. We are particularly delighted that one of the leading lights of our extended DAE, Department of Atomic Energy family, Dr. Anil Kakotka, readily agreed, and he is actually here. And so thank you, sir. Thank you so much. So without any further ado, I would like to give the floor to our director, Professor Jairam Chengalu. Yeah. And I would request him to felicitate Sunil with a bouquet of flowers. Thank you, Professor Chengalu. And now the TIFR Alumni Association also wants to express their love and appreciation for Sunil's achievement. So Professor Sri Ganesh Prabhu, on behalf of TIFR Alumni Association, will present a bouquet to Sunil. Thank you, Professor Prabhu. I now request our director, Professor Jairam Chengalu, to make the opening remarks.
Thank you, Indranil. It's a great pleasure to felicitate Professor Sunil Gupta, who's had a long and continuing association with TIFR for his election as President-elect of the IUPAP. And I congratulate him on behalf of the entire TIFR family. We've been seeing these pictures of the activities that Sunil has been involved in at TIFR. He has been a major driver behind the GRAPES experiment at the Cosmic Ray Laboratory at UTI. GRAPES is a ground-based cosmic ray observatory that studies cosmic ray secondaries produced through air showers. It's a very innovative instrument with, under Sunil's leadership, 2 major detector components, both largely developed in-house. These are an array of plastic scintillators, and again, you would have seen some images of those, which record air showers in the TeV to PeV range, as well as a tracking muon telescope that records atmospheric muons primarily to decode the mass composition of the cosmic rays. And in addition, the muon telescope also serves as a unique instrument to probe atmospheric and near-Earth phenomena using its high statistics angular muon flux momentum, muon flux measurements above 1 GeV. So the GRAPES instrument's unique near-equatorial placement allows it to study both the northern and southern hemispheres, and its relatively high altitude, about 2,200 meters above mean sea level, also helps reduce the energy threshold. And, so I think, although we are celebrating Sunil's election as president-elect, I did think it's important on this occasion for us to also acknowledge all of the work that he has been doing at TIFR over the last many decades. And with these unique capabilities, GRAPES has, of course, made several important contributions to the study of cosmic rays and space weather, And these include the evidence for hardening of the cosmic ray proton spectrum above 160 eV, estimation of the electrical properties of thunderclouds through muon imaging, as well as estimation of transient weakenings of the Earth magnetic field. So these are all observations which have had quite significant impact over the last several years. Sunil, of course, has been a champion for Indian physics, and it's a great pleasure to see him now assume this new role in the international physics community. And I'm sure it will enthuse all of my colleagues in the physics community, both here and elsewhere, to engage more fully with the IUPAP and with the activities of the IUPAP. And I'm sure that the IUPAP activities will also acquire fresh energy under his leadership, and we wish him all the best for that. Thank you.
Thank you so much, Professor Chengalu. I would like to invite Professor S. Ramakrishnan to express his opinion, views, and his short speech. Professor S. Ramakrishnan is a renowned experimental condensed matter physicist, and he obtained his PhD from TIFR in 1985, and he was a faculty member in TIFR till 2022 when he superannuated. He is Distinguished Professor Emeritus and Rajaramana Fellow at the ISER Pune since July 2022. His research activities are centered around superconductivity and magnetism and charge density wave ordering in rare earth elements. Professor S. Ramakrishnan.
Thank you, Indranil. I hope you can hear me. First of all, I'm extremely happy to know that, that TIFR is hosting this event to felicitate Sunil. Actually, I call him Sunil, Professor Sunil Gupta, on his extraordinary achievement. The fact that he is the second scientist who have got this recognition, the first one being our founder, Homi Bhabha, make this honor extremely, extremely noteworthy. I know Sunil more than 4 decades ago. I think thanks to my friend Arun Grover, who introduced me when I was a graduate student. At that time, I know that he was working in CRL, Cosmic Ray Laboratory, and using muon telescope to study high energy physics. But I came to know more on the working of the CRL when I became the dean. And when Musansir became the director, we both went to the CRL laboratory. Then I saw opened, actually, I got to know the excellent scientific staff which is nurtured by him. And of course, they paid him well by building this one of the best muon telescope in the world right now. And I could see the enthusiasm and the way Sunil was guiding these people. And, compared to the main campus, field station running is an extremely difficult task. And not only you need to do a proper man management, we also have to look at the research output and expand the facility. Because at that time, Sunil was on the verge of expanding this muon telescope facility so that he can get a higher resolution and so on. And he also showed me this, plastic scintillators, state of the art plastic scintillators, which is being made there. And of course, many DAE institutions also were interested in that. And I could see that, with very little money and a lot of enthusiasm, made that CRL, really a world-class facility for the detection of high energy physics rays using muon telescope. And things became even more interesting when I took as an interim director during my tenure. Not only interesting results on the high energy physics came out, but also the atmospheric science, Jairam mentioned a few of them, has come out of it. And it was very clear that UT CRL is the happening place as far as TFR is concerned. And not only that, then people from DAE units as well as ISRO, people working on atmospheric science were reaching out to me through and wanted to be part of a collaboration with OT, CRL at OT. And I think it was in May 21, I don't remember, that they had a really brainstorm meeting for 2 days meeting where all the participants from DAE, many institutes, many people from DAE as well as ISRO participated in that, and they were talking about not only looking at muon telescope, but also use the radio astronomy facility at UT to combine and study the space weather and so on. And it was very clear that this place is going to produce even more interesting results. And I think part of it is Sunil had a good backup, in the sense that Sashi helped him in the later part of the cosmic ray laboratory, especially the higher resolution muon telescope. Now, of course, Mohanty and Mohanty, of course, did bulk of the work in the recent times, and also ably joined by Ramesh. I'm sure that we need to have more academic input and also a bit of a manpower. I'm sure that CRL will become even more, the results would be even more startling in the future. And this is really the place. And I must also recall the contribution from our Japanese colleagues. I think without that, Seattle wouldn't have been the place where world would have got the recognition. And Professor Kawakami, I see here in the online, and he and his collaborators, I think Sunil will tell more about it. But I think their contribution to this center was extremely important. And I think I have said more than what I wanted to say. All I want to know is say that, I again congratulate Sunil on his extraordinary achievement. And I'm sure he will do well, because he has already done well as a chair of the Cosmic Ray Commission of the IUPAP. And I'm sure both IUPAP and India as a whole will benefit from his guidance. I think I'll stop here. Thank you. Thank you, Vindan.
Thank you so much, Professor Ramakrishnan. We deeply appreciate your kind words. Now, it's a distinct pleasure to invite Dr. Anil Kakotkar to say a few words.
Well, I have come here primarily to extend the warmest felicitations to Professor Sunil Gupta. I have been, of course, interacting with him for a very long time, but not on science, but on other related things. One thing that has been always sort of striking me and impressed me is the creative person that Professor Gupta is. His creativity in research is for all of you to, you know it better than me, because I'm not directly in that field. But for example, he today makes the best scintillator plastic, much better than many other places, and that has come about with a lot of efforts, perseverance. It has helped his research, but it has helped many other programs in the department. In the same way, once I was in Uti, and Sunil was surrounded by, I think, 40, 50 students, all from that engineering college in Pune, VIT, I think. And I was quite impressed, inquired about this, and then came to know that while students do their internship there, but he gets all his instruments done by. And if you calculate the resource that got mobilized in that small lab, was tremendous. And yet another aspect in the same vein is again, we're used to long telephone calls, sometimes running half an hour, 45 minutes, maybe even 1 hour. And he has ideas for, you name things, you start discussing, and he has his own ideas to share. I won't go into those specific points, but the sum total of all, once I remember, I think it was a review group of TIFR. This was at my time, long time back. But in the report, I don't know if that report is public or not, but maybe I can mention it on this occasion. In that report, they had made a special mention of Sunil Gupta and his work, and a recommendation that should not be seen as a kind of just one activity, but it's a very important activity, must be encouraged, must be expanded. And if I could understand things right, while Professor Gupta was talking about, this is essentially all around CRL activities. But here, I think already started talking about use of that lab for things outside cosmic rays and outside particle physics, dealing with climate, and of course, later, much later, dealing with space weather, for example. And that reminds me, not Sunil Gupta, but somebody else, in a discussion for reviewing a particular project proposal, there was this question that the proposal sought a new modern facility, saying that the existing instrument has become quite old and obsolete. And again, one person, I won't name, but a person from DAE fraternity, he spontaneously came back with a reaction that, look, instruments never become old. It's the ideas that become old. And I think that description fits Professor Gupta quite well. So I think I would dare say it's very appropriate that Professor Gupta, you have been elected to be the president designate on way to becoming the president of IUPAP, an organization which is known for retaining and propagating values, and an organization which upholds the spirit of science. And I'm sure you need such organizations even more today, in today's changing world, compared to the way things were in past. And I think time has come. It has been always so, but more so today, that science has to show the way. And I wish you all success in doing so. Congratulations, Dr.
Thank you so much, Dr. Kakotkar. Now, just a bit of an apology. I mean, maybe it is the excitement of the occasion that though I wanted to say a few words before Dr. Kakotkar started, which will be basically a ritual, nothing more than that. But nonetheless, since I missed it out, let me also, for our colleagues from outside India and on the Zoom, just read out a few sentences that Dr. Kakotkar, Anil Kakotkar, is a nuclear scientist and mechanical engineer par excellence. He served as the chairman, Atomic Energy Commission of India, and as secretary of Department of Atomic Energy from 2000 to 2009. Prior to that, he served as director of Bhabha Atomic Research Center from 1996 to 2000. Over his very illustrious career spanning 6 decades, He has received numerous awards, including Padma Vibhushan, the second highest award conferred by the government of India. The most importantly, something that I want to say, that he has been and continues to be a champion of India's self-reliance in energy sector, especially thorium as the fuel. Thank you so much, sir, also again for coming here and gracing the occasion and yours few sentences. The next, I would like to invite Professor Mustansir Burma. Professor Mustansir Burma, a renowned theoretical physicist specializing in statistical physics and condensed matter physics. He has served as the director of TIFR from 2007 to 2014. Professor Burma has been decorated with numerous awards and fellowships, including the Padma Bhushan, the fourth highest civilian award of the government of India, for his contribution to theoretical physics and science leadership. He has been intimately connected with the IUPAP and has served as chair of one of the commissions. Professor Burma is currently Professor Emeritus with TIFR Hyderabad, where he carries out his research and teaching. Professor Burma.
Thanks. Thank you, Indrani. Friends, I'm really, sorry. I'm really very pleased to be part of this felicitation of Professor Sunil Gupta to recognize this exceptional honor that has been bestowed on him. I could not make it in person, but nonetheless, I would like to share some thoughts about Sunil, his work and achievements, and a little bit about his involvement with the IUPAP. So let me begin by recalling a day in 2007. Actually, Ramki, in his brief presentation, also recalled the same point. So he and I, Ramki and I, Professor S. Ramakrishnan and I, visited the Cosmic Ray Laboratory in Uti at that point. It was a very short visit, little more than a day, but one that left a deep impression on us. The hillside, peppered with muon detectors, is a perfect amalgam of high science and a beautiful natural setting. I mean, for those of you who have not been to Uti, please go just to have a look at this beautiful array. We were equally impressed by the team of bright young scientists and engineers who had built and maintained the GRAPES 3 facility. The GRAPES 3 experiment was initiated by Professors B.V. Srikantan and Suresh Tonwar and has benefited from over 2 decades of strong involvement and leadership of Professor Sunil Gupta. Sunil always had a passion for developing instruments, especially radiation detectors, and it was the development of high-quality high-quality plastic scintillators by him and his team, which gave the CRL its scientific edge. During our visit, we were impressed by 2 numbers. The first was the sensitivity of the detector, which was high. The second was the cost, which was low. Sunil was justifiably proud of both aspects. The detection techniques, of course, as has been mentioned already, has had applications beyond basic science for atomic energy and space, and several very focused and important applications in these areas. My own expertise is not in high energy astrophysics, so I won't talk about the physics from CRL. I only note that it is an out-of-the-box application in which the array was used to track solar events, which led to a temporary weakening of the magnetic field which surrounds the Earth, was a contribution with a great impact because it led to the mitigation of space weather disturbances, a method to mitigate space weather disturbances. I also mentioned that Sunil has built up networks of various sorts. And I mean, I don't mean electrical networks, I mean networks, human networks. Strong collaboration with Japanese groups has already been mentioned. And also the other point that Dr. Kakotkar brought out was very, very, prominent and important, namely to enlist young students working towards degrees in engineering to do projects at UT. The active collaboration of VIT Pune was enlisted for this purpose, and in fact it was facilitated by a TIFR alumnus, Professor C.S. Garde, who was a faculty at VIT. More than 200 students participated in this program, and as Dr. Kakotkar said, it worked both ways. The students got trained, and many things got built at UT. So it was a win-win situation. Professor Gupta's involvement with the IUPAP began with the C4 Commission. As you know, the IUPAP is comprised of 20-odd commissions, each dealing with a subfield of physics, and C4 deals with high-energy astrophysics. Actually, earlier C4 used to be called the Commission on Cosmic Ray Physics, and I think the change of nomenclature took place around the time that the C4 Commission was chaired by another TIFR person, namely Professor Suresh Tonwar. At that time, this changeover took place. In any case, Sunil Gupta was a member of C4 between 2011 and 14 and continued on the commission as vice chair between 2014 and 16, and then finally was appointed chair of the commission and led the C4 commission between 2017 and 21. As chair, of course, besides dealing with the day-to-day affairs of the cosmic ray community, he had a leading role in organizing the biennial IUPAP International Cosmic Ray conferences, and also in selecting the recipient of the Homi Bhabha Medal and Prize. So this is an important medal and prize given by the commission, but the recipient is always chosen jointly by the C4 Commission of the IUPAP and TIFR. By the way, Sunil himself was awarded the Oak Prize by the commission a little later. Now, as you know, the IUPAP as a whole is headed by the president, who was chosen 3 years in advance. And past presidents of the IUPAP include luminaries such as William Bragg, Neville Mott, and many others. And of course, our own Homi Jahangir Bhabha. Dr. Bhabha is the only Indian to have held this position so far. Now, in the 33rd General Assembly of the IUPAP, which was held in Haikou in Hainan province in China, the General Assembly elected Professor Sunil Gupta to serve as President Designate between 2025 and 27, to be followed by a term as President IUPAP thereafter. So this is indeed a singular honor. For all of us at TIFR, it is a proud moment to see our alumnus, our faculty, our friend, one whose full scientific career has blossomed in the institute, to see him being recognized as the head of this most important scientific international union. We have no doubt that the union will prosper under his leadership, and we wish him all the best in this endeavor. And I would like to end by offering Sunil my heartiest congratulations and felicitations on this occasion. Thank you.
Thank you so much, Dr. Burma, for your very kind and insightful words. Next, I would like to invite Sunil's long friend and colleague, Professor Arun Grover, to say a few words. Professor Grover is an experimental condensed matter physicist who served for 2 terms as the Vice Chancellor of the Punjab University in Chandigarh from 2012 to 2018. He served TIFR for over 4 decades from 1972 to 2016. He is recipient of many awards and fellowships for his contribution to experimental condensed matter physics, He has been a member of IUPAP Commission C14 on physics education since 2002. His current interests include the history of higher education and scientific research in India. Professor Grover.
I am indeed very delighted to have this opportunity to felicitate and congratulate my TIFR graduate school colleague, Professor Sunil Gupta, for the coveted position of President-elect IUPAP, a responsibility executed by Dr. Bhava 65 years ago as the 7th President of IUPAP. So today's event is organized by TIFR Alumni Association. And this Alumni Association came into being in 1999 after the review of 50 years of TIFR by an international committee headed by none other than Lord Porter, the then president of the Royal Society. So one of the recommendations of that committee was that the outreach of TIFR should be enhanced. So the Alumni Association was a consequence that TIFR Endowment Fund, TIFR Alumni Association, etc. followed all that. The TIFR Alumni Association is unique in the sense that its membership is open to not only the students who have studied at TIFR, but also all the postdocs, any scientific officer who has served at just for a period of 1 year or more, and of course, all the faculty members who superannuate from TIFR. So during 80 years of its existence of TIFR, the TIFR has been enriched by many of its very illustrious prized students, postdocs, and the distinguished alumni. Dr. Bhava, as you all know, got his FRS in 1941. And in 1942, when after his father passed away, he decided not to return to England and work in India. And he embarked on this experimental cosmic ray research program. Prior to that, from 1932 onwards, he was engaged in theory, high energy phenomenology, with the cosmic ray experimentalist used his insights or he interpreted those things. But the experimental program was commenced only from 1942 onwards. And it's in 1943 that Bhava got his first Indian PhD student in the form of Harish Chandra, who was sent by Professor Krishnan from Allahabad University. Harish Chandra had been known to Nobel laureate Raman as well, because Raman had set up a question paper for Allahabad University in which Harish Chandra had answered only one question. But that was the toughest question, and Raman had not expected anyone to solve it at all, but he had solved it completely. Of course, he took all the time and couldn't attempt anything else. But Krishnan sent him to work with Bhava and not with Raman. So as the story goes, TIFR was conceived by Bhava in August of 43. TIFR comes into being in 45. 1st June 1945, TIFR is commenced from Bangalore. And then Bhava decides to shift to Bombay quickly. And he comes to Bombay, but he sends Harish Chandra to work with Paul Dirac. He had set him to work with him on ideas which were more mathematical in nature, things which were related to applications of group theory, etc., etc. But Bhava was conscious that once he goes to Bombay, he will not have time to do. So he sends him to Paul Dirac, and thereafter he transforms into a mathematician, and the rest of the story we know. Anyway, after coming to TIFR, Bhava had string of very good students. Of course, Professor Shrikantan, B.V. Shrikantan, who had several offers. His first wanted to do engineering. He wanted to do communication engineering with a professor in Bangalore. Then he had an offer to do cosmic ray research with D.M. Bose at Calcutta. But he chose to come to join Bhava. And soon after, Sitaraman joined. Then came Udgaonkar in theoretical physics. Then Devendra Lal and Yashpal. And of course, Professor Daniel was there doing mentions with Bhava even from 1947 onward. Thereafter, it was George Sudarshan, it was Vijayaraghavan, Iyengar, and G. Venkatraman. These were the students who joined Baba. Of course, Bernard Peters had come in and he was looking after those experimental students. But there were also fresh PhDs that Baba had hired, and that included Ramanna, Kundan Singh Singhvi, R.C. Majumdar. Even Brahm Prakash joined TIFR on staff first, and then he was transferred to IISc Bangalore. Biswas, Bibha Chaudhary, Dharmati, Asundi, and Menon is, of course, joined in 55. I gave you all these illustrious names because all these people went on to build all this scientific infrastructure that you see in India, even after Baba has left. So after Baba, the TIFR graduate school was commenced soon after 1968. And then there was this TIFR graduate school in which students were joining for PhD. And TIFR had stopped inducting a handful of students that TIFR used to get from BRC training school for its experimental programs, large experimental programs. So there was this students who come for a short time, and then there are these bright scientific officers who came from BRC who built this large experimental programs, which became a USP of TIFR. So after Menon, Professor Srikantan took over as a director in 1975, and he's had a review at what TIFR was doing at that time. A committee was appointed, and that committee gave recommendations as to how to sustain the large-scale experimental programs of TIFR, because this time-bound PhD program was not getting adequate number of manpower for the large-scale programs of TIFR, which was a USP of TIFR. So one of the recommendations was that a TIFR should start a research trainee scheme parallel to the research scholars who came for a fixed period of time. They have to complete PhD and go away and so on and so forth. So Sunil joined as a research trainee in the year 1977. And lo and behold, he joined Professor Srikantan's experimental program, which was running at OT since the mid-60s. Okay. The program had been started a little earlier, but since the mid-60s, it was in full stream, and actually this Cosmic Ray Lab. So it had this interestingly sounding, this gamma ray astronomy at beta electron volt energies, GRAPE. So GRAPES 1, 2, 3. So few decades down the line, Sunil became in charge of this GRAPES 3 experiment after the superannuation of Professor Tonwar. Okay, and in the last 20 years, we all know that Sunil took this GRACE program to a higher level of performance and higher level of excellence. And by virtue of the output of this experiment, which is an Indo-Japanese, it's an Indo-Japanese collaboration running for now about 60 years, 6 decades. This kind of an international collaboration. There are not many examples in India of this kind. So in 2023, Sunil was awarded OKLA medal at the Biennial International Cosmic Ray Conference in recognition of his significant contributions to the field of astroparticle physics over an extended career, and for his leadership of GRAPES 3, which had made notable contributions to the solar terrestrial physics, which Mustances told us about, and for his diligent services to the cosmic ray community, both in India and worldwide. This OKLA prize, as Mustances told us, has been won by P.L. Ginsburg, Nobel laureate Ginsburg, and from India, Ramnath Kaushik has been a recipient of this prize earlier, and Ramnath was a graduate student who came to TIFR from the BRC training school route. So Kaushik was from the training school route, and the Sunil came from the research training route of the TIFR graduate school. So I have had a very close personal relationship with Sunil. I am a condensed matter experimentalist, very little overlap with what Sunil does. Of course, once in a while, I did go and see how he was growing his scintillators and so on, but I didn't participate in it, honestly. So, but I had some role in the initiation of what we called as Scientific Forum of TIFR in the early 90s. And Sunil also was the president of the Scientific Forum of TIFR for a year, 1994-95. So when the Lord Porter came and the then president of SFORT, Professor Naveen Singhi, who is there with us, he and led the ex-presidents of SFORT to meet Lord Porter. And we gave lots of our suggestions. And he summarized some of our suggestions. And it is in that report only that he said the outreach of TIFR should be enhanced. And then we took upon ourselves that we should create a TIFR Alumni Association. And the Alumni Association should take a leading role in enhancing the outreach of TIFR. That is why it's the Alumni Association which organizes the TIFR Science Day lecture, the R.D. Tata lecture, Teachers' Day lecture, etc., etc. Even the TIFR Foundation Day lecture, which was commenced in the birth centenary year of Baba, the TIFR Alumni Association played a role, and Dr. Kakotkar gave the first TIFR Foundation Day lecture, you will recall, on the 1st of June 2009, when you gave us the then present status of the three-stage program of Dr. Homi Bhabha. At a more personal level, so our son and Sunil's son went to the same naval public school. They went to do BTech from Karnataka. Then they worked for the corporate world in Bangalore for a few years before they went away to America, where they presently serve. I have visited Ooty several times, and courtesy Sunil, I had the pleasure of having dinner with Dr. M.R. Srinivasan and Mrs. M.R. Srinivasan twice. We also visited their home once. And I would like to wish Sunil a very fruitful innings as a member of the executive committee of IUPAP for 9 years. IUPAP today has 20 commissions. In 14 of them, India has a representation. And IUPAP, every commission of IUPAP is supposed to hold one flagship conference once in 3 years or some such thing. So, courtesy Sunil, I became a member of the IUPAP Commission C14 a few years ago, and we are hosting the flagship conference of physics education in December of 2025 at IIT Ropar in partnership with Aiza Mohali and the Indian Association of Physics Teacher, and Professor P.K. Aluwalia, who is the current president of the IAPT, is also attending this event. And we have made all the 14 Indian members of the various commissions of IUPAP as a member of the advisory committee of this ICP 2025. Last time it was held in India was 2005, when Dr. Kalam was attended and inaugurated that event, and 1,500 people are supposed to have attended this conference in Vigyan over a 5-day period. We may not be able to do it in that grand a scale, but we are looking forward to welcome Sunil to be there. Incidentally, the president of C14 is Professor Manjula Sharma from Australia. She would be there, Sunil would be there, and I hope many of the members of IUPAP from India would be attending that event. So with this, Sunil, I offer you the fullest cooperation from all the members of IUPAP. I have personally written to all of them that we are around in December in IIT Ropar, when Sunil will be there amongst us. And let's contribute as much as we can to the international physics effort during the 9-year tenure of Sunil as a member of the executive of IUPAP. Thank you very much.
Thank you so much, Professor Grover. So the next speaker is Professor Saburo Kawakami. It will be open on Zoom. Professor Saburo Kawakami is with the Osaka City University, now Osaka Metropolitan University, Osaka. He is a leading authority in cosmic ray physics who has been active for past 6 decades. Professor Kawakami worked first in the KGF underground experiments from mid-1960s until 1992, when the gold mines were closed. In 1993, along with Sunil Gupta, he became one of the founding members of the GREPS 3 collaboration. He is credited with developing the robust large area proportional counters, which were used in making the most sensitive muon telescope in the world. Professor Kawakami.
Thanks for the guiding me. I hope you can hear me.
Yes, we can hear you.
Okay, thank you. All right. First of all, I would like to express my sincere gratitude for being invited to such a celebratory occasion and for being given the opportunity to deliver a few comments. Looking back, I believe it was in the early 1990s when I began to my joint research with him. So it has already been more than 30 years. In normal course, it would have been appropriate to start by directing my remarks at him. However, as the eldest among the collaborators, I hope you will allow me to take a little time to talk about the history of our Indo-Japan international collaborations. One of the few privileges or perhaps obligations of a senior member is to recall and share old stories, though certainly I'm afraid it often comes with long and winding talks. Anyway, the Japan-India collaboration is continuing since the mid-1950s. It was started by Professor Pablo Miyake. He is my group of Osaka City University, and Professor M.G.K. Menon, then Deputy Director of the TIFR. At that time, in KGF, a series of cosmic ray muons intensity measurements were conducted at various underground depths. Finally, not a single muon could be detected at the deepest underground. So, its depth is around, I remember, 2.3 kilometers below surface. Then it became the site of the neutrino experiment, which involved the Indian, Japan, UK group. This collaboration successfully detected world's first atmospheric neutrinos. It was quite a significant result, I think. While I cannot say for certain, our collaboration may be one of the longest running international scientific research collaborations of its kind. Of course, mere longevity has little meaning on its own. At the beginning of the collaboration, some 70 years ago, the main purpose was to advance, of course, the advanced cosmic ray research through joint effort. However, I also recall how Professor Menon emphasized the importance of training young researchers and engineers through the introduction of cutting-edge observation technologies. He was strongly advocating for domestic development of electronics, computing, and related technologies in India. Thinking of how this technology was used to make the first observation of atmospheric neutrino, and of course, the success of the GREPS 3 project, currently conducted at Ooty, under the outstanding leadership of Gupta-san. In the early 1980s, the first proton decay detector was constructed, followed by the construction of larger second detectors. Observations continued to late 1990. but unfortunately we had to stop the underground experiment due to the closure of the Kola gold mine. So at that point, it seems that our Japanese-Indian joint research might come to an end. However, thanks to an offer from Professor Tonwa, we were able to continue collaboration on air shower study at the Cosmic Ray Laboratory in Mount Uti. So, around the mid-1990s, construction of a third phase of air shower array was initiated at Uti, and observations using a large muon telescope commenced in 2000. And it continues to this day. The construction of a second large muon telescope has been nearly completed, and some observations have already started. The Indian representatives of our collaborations have included Professor M.G.K. Menon, Professor V.S. Narasimham, and Professor Suresh Tonwar, and subsequently Professor Sunil Gupta. I call him as Gupta-san. So we have been fortunate to work with many excellent collaborators and graduate students over the years. Among them, I especially recall the significant contributions made by Professor B.V. Srikantan. From 1967, when I joined the collaborations, for more than 20 years during the KGF underground experiments, there was always at least one Japanese researchers stationed on site. And a long-term stay by Indian academic members, and maybe it was half a year or 1 year, more than 1.5 years like that, were also so common for them. In particular, active participation in equipment construction on site was considered a fundamental rule. This understanding has remained the foundation of our collaboration to this day. For example, no formal agreements or memorandums existed for the KGF experiment. I clearly remember when budget for our Japan-India joint research program was approved by the Japan Ministry of Education, they requested us to show the written agreement, which we didn't have that time. So, MOU was hurriedly drafted between Osaka City University and the Tata Institute of Fundamental Research. Even at the start of the GRAPE 3 experiment, no formal written documents were exchanged. However, the project was launched based on a personal relationship of trust between Professor Tonwa and myself. And I believe that spirit still continues today. The remarkable contributions of Gupta-san to the project are truly outstanding among all the collaborators I have ever worked with. I sincerely appreciate his dedication. Without his deep insight into physics and full-time passion and selfless devotion to experimental work, the GRAPE 3 project would likely have taken a very different and unfortunate path. But I confess honestly, I never expected him to become the president designate of IUPAP. However, considering his outstanding work on GRAPE 3 and his abilities, I must say that he has indeed found a very suitable stage to continue contributing to the advancement of physics. I sincerely hope that he will make significant contribution to the further development of physics through IUPAP.
My relationship with him began through cosmic ray research only, has grown through many of his visits to Japan, and he has become a very good and trusted friend of mine now. And currently, the Japanese representative of Grade 3 experiment is Professor Oshima from Chubu University. He happened to be one of my students. I'm pleased to report that Japan's Ministry of Education has recently approved nearly $400,000 in research funding. It means they have recognized the excellent results of the Grade 3 experiment, and this will facilitate research activities and researcher exchange over the coming years, further contributing to the development of present collaborations. I remember his visit to Japan was in 2023 with the invitation from Chubu University, where he is a visiting professor since 2019. I very much look forward to seeing him again in Japan in the near future. And forgive me a little more comment. Finally, I would like to express my deep gratitude to Professor Hayashi. He is my longtime colleague. His unwavering dedication to the collaboration from KGF to UTI over more than 40 years has been an invaluable source of support to me. So here I would like to conclude by expressing my heartfelt hope for the continued development of our collaboration. Thank you very much for your kind attention. Congratulations, Gupta-san. Thank you.
Thank you so much, Professor Kakami, for your very kind words. So we move on. The next speaker on our list is astronaut Luca Pamitano. I'm still not very sure that Colonel Pamitano is there on Zoom. Colonel Pamitano? There? Colonel Pamitano, if you... It seems that he will join a little late. So we go to the next speaker. The next speaker is Professor T. Kajita. He is one of the foremost experimental neutrino physicists in the world, whose experimental research at the Super Kamiokande helped prove the neutrino oscillations and that neutrinos have mass. Professor Kajita shared the Nobel Prize in Physics with Canadian physicist Arthur Bruce MacDonald in 2015. Their path-breaking work solved the long-standing solar neutrino problem. Other notable recognitions are the Asahi Prize, Bruno Rossi Prize, Nishina Memorial Prize, Panofsky Prize, and the Breakthrough Prize in Fundamental Physics in 2016. It's my distinct honor to invite Professor Kajita to say a few words.
Thank you very much. Well, actually, first of all, I would like to congratulate Professor Sunil Gupta for being IUPAP President Designate. And I have prepared some slides. Therefore, I want to share my slide. Okay. I want to talk about Professor Gupta and the International Cooperation on Cosmic Rays. First of all, I would like to show this page. This photo was taken about 60 years ago. This was India, Japan, UK collaboration at Kola Gold Field. And in fact, in 1965, atmospheric neutrinos were observed for the first time. And thanks to this discovery, later, we were able to study more on atmospheric neutrinos. Oh, by the way, I want to mention that this photo I received from Professor Gupta. Well, the previous page was 60 years ago, but I want to mention that India-Japan collaboration is continuing. Well, on top left, I show a KGF proton decay experiment, and right bottom, this is grade 3 experiment, where Sunil has been working and leading. So I believe India-Japan collaboration have been great success. Now, since in the past, we had a great success in cosmic ray cooperation, therefore we thought we should continue the successful collaboration on cosmic rays. And therefore, Sunil arranged the signing of memorandum of cooperation between TIFR and ICRR. And we signed on March 31st, 2022, which was my last day as the ICRR director. And well, I would like to particularly thank Sunil for his special arrangement. And here I show some photos where this signing ceremony was done online. And in addition, Dr. Ramakrishnan and Tata Institute for Fundamental Research and myself, ICRR, signed. And we agreed that we'll continue working together on cosmic rays, in particular in the grade 3 and hyper-K experiments. Now, I would like to move on to IUPAP C4. The Commission on Astroparticle Physics, C4, previously known as the Commission on Cosmic Rays, was established by IUPAP in 1947 to promote the exchange of information and views among the members of the international scientific community in the general field of cosmic ray physics. That was broadened into the wider field of astroparticle physics later. And Sunil has contributed to IUPAP C4. In 2009, he became associate member. 2011, became the member. 2014, vice president of C4. And 2018, vice chair of C4 in 2014 and chair of C4 in 2018. And in fact, I think he did a great job as the chair of C4. And here I would like to show a photo we took while Sunil was the C4 chair. This photo was taken in a symposium on cosmic rays in Nagoya. And I joined C4 in 2018 as an associate member. Sunil asked me to join, and I agreed. Then when Sunil finished his term as the C4 chair, he asked me to take the role of C4 chair. Actually, I was not sure if I should accept this invitation because I wasn't sure if I can. But in the end, I agreed to serve as the C4 chair starting in January 2022. And I would like to particularly thank Sunil because during my term, Sunil helped me a lot on the C4 issues. Without his help, it was simply impossible to finish my term. Thank you very much. Now, 2 years ago, in Japan, in Nagoya, we had International Cosmic Ray Conference. International Cosmic Conference is the most important conference for C4. And we had this conference in Nagoya, and we were very happy to present O'Kelly Medal to Professor Sunil Gupta at the opening ceremony of ICRC 2023. And here I show a photo that Professor Sunil Gupta received O'Kelly Medal from the representative of the Dublin Institute for Advanced Studies. And well, here at the bottom of this page, I simply copied the official statement. O'Kelly Medal winner, Professor Sunil K. Gupta, for his leadership of the Grade 3 experiment at the Cosmic Ray Laboratory in UT, which has made notable contribution to solar terrestrial physics, and for his diligent services to the cosmic ray community, both in India and worldwide. Well, certainly, I believe this medal was should be given to Sunil. Now, also I want to mention about the IUPAP General Assembly meeting in October last year. Sunil gave a talk as the president designate of IUPAP at the 33rd IUPAP General Assembly meeting in October in Haikou, China. He presented his journey as a physicist. And I was most excited to know how successful Sunil and the Grade 3 experiment have been. And also, personally, I was very happy that Sunil mentioned the India-Japan collaboration in his summary page. I'm sure that Professor Sunil Gupta will have another success as the president-designate of IUPAP. Well, once again, congratulations, Professor Sunil Gupta, for president-designate of IUPAP. And I'm confident that Sunil will further advance IUPAP with the development of physics and international cooperation in physics. Okay, that's all from me.
Thank you so much, Professor Kajita. Since Colonel Luca Palmitano is yet to join, we move on to the next speaker. The next speaker is Professor Shubir Sarkar from Oxford. He's currently Professor Emeritus in the Department of Physics, University of Oxford. He received his PhD from TIFR in 1982, and subsequently he held visiting positions at CERN, Rutherford Appleton Laboratory in Oxford. He has been associated with the Rudolph Field Center for Theoretical Physics, Oxford, since 1990. He headed the particle theory group there from 2011 to 2019. Some of the major awards and fellowships won by him include Bruno Rossi Prize of the American Astronomical Society, Niels Bohr Professorship at Copenhagen from 2013 to 2018, IUPAP TIFR Homiva Medal and Prize, Vaibhav Fellowship of the Government of India. Professor Sarkar.
Thank you so much. Thank you for having me. May I share some slides, please?
Yes, please go. Yeah.
You have to allow sharing for the meeting?
Yes, please go ahead.
I see. Okay, thank you. I've got it now. Well, here is a picture of the Cosmic Ray Lab at UT I've already seen, which is really Sunil's spiritual home. And I'm really delighted that I've been invited to participate on this happy occasion, because it's always nice to celebrate a friend and a colleague for many years. In fact, I've known Sunil for nearly 50 years. He joined TIFR as a research trainee in 1976 couple of years after I had done. And because we both worked in cosmic ray physics at the time, obviously we got to know each other. This photo was taken many years later when he visited Uti, and you can see what a nice place it is. Sunil was in fact appointed to the staff in TIFR just a couple of years after he joined. This was the practice at the time, going back to Dr. Bhawa's initiative in this matter, that people in experimental physics groups should be absorbed. Now, he has subsequently spent 44 years at TIFR since until he retired in 2020, having worked his way up through the academic ladder. I, in fact, left in 1984, but we re-established contact about 20 years ago when he invited me to lecture at the school on astroparticle physics that he has been organizing in Uti and also co-organizing in Darjeeling for quite some years. And at this point, I became a regular visitor to Uti and also helped him to organize a couple of meetings. There was the Corsica School, a rather important feature on the astroparticle calendar, and also the TeV Particle Astrophysics Conference, which we in fact held at TIFR. So I would say that I've interacted quite a bit with Sunil over the last 20 years, and I have had the opportunity to see for myself what he has achieved at the Cosmic Ray Lab, which you have already heard about from people who know it even better than I do. We have heard that Sunil was principal investigator of the Graves 3 experiment, which is continuing to this day as one of the leading experiments in air shower physics in the world. And I have to say that when he was awarded the Okele Medal by IUPAP at the 2023 Cosmic Ray Conference, it was a very special pleasure to be able to present it to him and read his citation on that occasion, which was to honor outstanding contributions in cosmic ray physics. And you have already heard why he very much deserved that. So the laboratory that Sunil has built up over the years at Uti is not just a building. More important, I think, are the people that he has, the team that he built up there, the people that he trained, students, technicians, academic staff. And here are a few pictures to show you the scale of the project. Not only the scintillator array on the hillside, also the muon counters that are, in fact, in the last stages of now being completed, all done with the collaboration of our Japanese colleagues, which has been very fruitful over the years, as you have already heard. In fact, this Uti laboratory has been nominated as a potential national cosmic ray center and a hub for astroparticle physics in India. And let us hope that Sunil's successors will work successfully to making that a reality. Now, this has been mentioned by other speakers before me, but I cannot resist saying this, that his success is clearly due to the fact that he recognized that the very challenges that face experimental physicists, especially in India, for lack of resources, import controls and so forth, Sunil kind of turned it around and made it into a challenge which he used to motivate young people. And this spirit of doing things on the cheap, jugaad as we call it in India, has been rather successful. Of course, just having the motivation is not enough. In the end, you have to deliver, because there are no handicaps on the international stage. You have to perform as good as your competitors elsewhere. And it is remarkable that he has been able to do so. We heard already from Professor Kakodkar about the development of world-class scintillators for a fraction of the cost at Uti. And there have been many other developments in instrumentation and laboratory techniques. And in fact, these have not only been important for the fundamental physics program regarding cosmic rays, but have also found applications within the Department of Atomic Energy and ISRO. And that, of course, has helped in ensuring both collegiality within these institutions, but also, if you like, enhanced TIFR's standing in terms of not just being a center where leading work is carried out in fundamental physics, but also in developing instrumentation and techniques. So here is Sunil today, and I would like to, if I may, quote some words from a famous Indian physicist, our first Nobel laureate, which I think have inspired Sunil all these years. And this is from the Hindu newspaper of 1942, and I will read it out. It might be a little difficult to read on the screen. Says, I can assert without fear of contradiction that the quality of the Indian mind is equal to the quality of any Teutonic, Nordic, or Anglo-Saxon mind. What we lack is perhaps courage. What we lack is perhaps the driving force which takes one anywhere. We have, I think, developed an inferiority complex. I think what is needed in India today is the destruction of the defeatist spirit. We need a spirit of victory, a spirit that will carry us on to our rightful place under the sun, a spirit which will recognize that we as inheritors of a proud civilization are entitled to a rightful place on this planet. If that indomitable spirit were to arise, nothing can hold us back from achieving our rightful destiny. So this was, of course, in colonial India when it was still under the British rule. Professor Chandrasekhar Venkata Raman addressing students at Patna University in 1941. And I think that even if it is now many, many years later, these words still resonate with many of us. So Sunil is, of course, now moved on to expand his horizons further. Now he hobnobs with Nobel laureates. We have just heard Kajida-san, and soon we'll also have Professor Barry Barish and Professor Sam Ting speaking. So I'd just like to conclude by saying I wish Sunil the very best in his role as president of the IUPAP, which I'm sure he will lead on to even greater heights. Thank you very much.
Thank you, Professor Sagar, for very kind words. Colonel Pumped, but Eleanor. Okay. So we move on to the next speaker. It is my pleasure to invite Professor Michel Spiro to deliver his speech. Professor Michel Spiro, a renowned high-energy and astroparticle physicist. He has served as the director of IN2P3 in CNRS, France. Professor Spiro was president of CERN Council when Higgs was discovered. He is currently serving as the past president of IUPAP. Professor Spiro. Please unmute yourself, Professor Spiro. Parag.
Okay, thank you. Thank you very much for inviting me to say a few words at this occasion of a felicitation of Sunil Gupta. So let me share also a presentation, so I will try to do that. This will allow me to say more congratulatory remarks and tribute to the work Sunil did for IUPAP, and which turned into Sunil becoming the first president of IUPAP, now president designate, but the first after Dr. Homi Bhabha. So I will make a short presentation of IUPAP and try to insist on the role of Sunil. So IUPAP, the mission of IUPAP has always been, and it's still, to assist in the worldwide development of physics, to foster international cooperation in physics, and to help in the application of physics toward solving problems of concern to humanity. We have added recently further IUPAP principle, foster openness and inclusiveness, promote free circulation of physicists, and this is particularly important nowadays, and of data, ensure integrity and credibility, promote physics as a building block of innovation and multidisciplinary research, promote physics as an essential tool for development and for sustainability. No one better than Sunil incarnates all these values. So IUPAP has a long history. It is 100 years old. It started in 1922 with the first 13 countries. And the first president was William Bragg. The first General Assembly was in 1923. Then, as you know, recently we have appointed our new presidents. These are Silvina Panse-Dawson from Argentina, she is president. Sunil Gupta from India is president designate. And myself, I am now past president from France. So you see that you have emerging countries in IUPAP. India had already a president, Baba, but we have now someone, a lady from Argentina. So there is a big change in IUPAP, and you will see that moreover. The members, there are 60 member countries, territories. You can see all these territories associated to countries, most of them. The new ones are Bulgaria, Egypt, Jordan, Uruguay, and Ukraine. We are introducing now corporate associate members. We have already almost 10 corporate associate members. And we are also getting associate territorial members. Nepal started joined in this position, and we hope to have territories from Africa very soon. We have also the 4 regional physics society, which are observers, American, African, Asian, Pacific, and European. So this is a map. You see we're lacking territories in Africa, but we are quite well covering the world. As it was mentioned, we have many commissions. The first one, which is very well known, it is on symbols and units. The International System of Units, IUPAP is the founder of this system. And we have many commissions covering all fields of physics, in particular astroparticle physics, C4, which was mentioned many times, because Sunil played a major role in this commission. It's a new name, it was mentioned also. Before it was cosmic rays. We have affiliated commissions, which are already quite independent, but connected to IUPAP for optics, for general relativity and gravitation, acoustics, medical physics, physics students, and history and philosophy of sciences. So it's our border unions. We have also working groups. One famous ICFA for future accelerators, women in physics playing a major role to push for more women in physics. This was initiated by Bert Richter some time ago. We have on lasers, on nuclear physics, on gravitational waves, and so on. More recent, on ethics, on quantum science and technology, on open science, on physics for climate change, action, and sustainable development. Some have very close links with the OECD and contribute to roadmaps. The main activity of the conferences, there are 2 main activities. One, which is to organize worldwide attended conferences. We have already 50 conferences per year, which are mostly organized by commissions, sponsored by commissions. The requirements are the scientific interest, the worldwide attendance. Again, this is quite difficult now, with no a priori restriction or difficulty to attend, and inclusiveness and diversity. The other very important action is giving prices. We heard about the prices from C4, which was awarded to Sunil. But we also created recently the Early Career Scientific Prize Awards, which is very important. We already awarded about 250 prizes between 2006 and 2024. We have projects. I will mention 4 of them. Gender Gap Project, this is connected to the working group Women in Physics. So you can see here Silvina Ponce-Lawson, our new president now. She was chair of the working group of Women in Physics. But this was inter-union projects with mathematical union, chemical union, and so on. These projects aim to analyze the gender gap in sciences and to try how to measure it and how to reduce it. Now it is a standing committee on gender equality in sciences. We have a very strong project which was initiated by IUPAP for light sources for Africa, the Americas, Asia, and Middle East project, following the example of Sesame in Jordan, where all the Middle East joined forces, including Iran and Israel. So you see that it is not easy this time, but it's still surviving the difficult times. So there is a light source in Jordan used by all the Middle East, and we would like to promote light sources like Sesame in Africa, the Americas, so Latin America, Asia. We were the initiator of the International Year of Basic Sciences for Sustainable Development, 2022-2023. IUPAP was a leading union with a lot of other unions and organizations, a lot of academies. And we have now obtained a decade of Sciences for Sustainable Development, 2024-2033. We are also playing an important role in the International Year of Quantum this year, 2025. So IUPAP is playing a major role in both of them, the decade and the Year of Quantum. And I use this opportunity to invite you all to participate. We have a newsletter which I invite you to subscribe to. So I come now to Sunil it's a very long journey of Sunil had a long journey in IUPAP. He started. It's already 30. He started 13-year journey with a C4. You heard already that he served for 13 years. For 13 years, he was associate member in 2008, member in 2011. He became vice chair of C4 in 2014, when C4 changed its name from cosmic rays to astroparticle physics, and he became chair in 2017 till 2021. He always served in the only interest of IUPAP, and after this long-term service, 13 years, we thought that this was the end, and in December 31, 2021, he delivered a farewell speech to all the people he worked with. So this is the beginning of his speech. It is a famous speech, which was very well appreciated at the General Assembly by all people. He mentioned the interaction he had with all the commissions, in particular with Claes Falander, chair of C12, Sekazi Tingwa, chair of 13, who replied to him. I just want to show the various replies. Hello, Sunil, your message was truly poetry of the highest order. It reflects your always kind spirit, and we all will miss you tremendously. However, let us not be strangers, but stay in touch. As for the rest of the IUPAP community, since unlike Sunil, I am not a gifted poet, let's kindly offer a second upload to Sunil's message. I am sure we all feel the same. So this was Sekazi Tinga, chair of C13, the Commission for Physics for Development. Now a message from Claes Falander. It was wonderful to read your message. It brought back many fantastic memories. I will miss you. In fact, I would like to support Sunil's message of hope, the hope that we'll see each other sometime again in the future. I am convinced that you will keep up the great work of IUPAP in the years to come, and with that, I wish you, all of you, all the best for 2022. So this was end of 2021. He also thanks the interactions with the president at the time. He mentioned also Silvina. At that time, she was the chair of the working group 5 and becoming a president designate. Monica Pepe Altarelli, who was in charge of organizing the centenary celebration. Laura Green, who became recently the vice president for ethics and communication outreach, and who was the advisor to Joe Biden. And I will show you the replies. A reply from Laura Green: your warm and positive message is an inspiration to all of us. We all appreciate all of the details to remind us of our accomplishments and of the deep respect we all have for each other. I am often asked by my friends and family if my committee, so this was her commission and her vice presidency, and other service work against me any monetary rewards, and it is hard to explain why we do that pro bono. And this is what Sunil did for 13 years. It was pro bono. Your message makes it clear. Would you consider writing a more general monograph explaining this? You have the background and talent. Laura Green. Now, Monica Pepe Altarelli. Dear Sunil, what a lovely message. Thank you. We are all grateful to you for your wonderful friendship and cooperation. I sincerely hope that our paths will cross again. Happy New Year, Monica. So this was again end of 2021, beginning of 2022. And surprise, so we thought that Sunil was that we will miss him. In fact, we missed him for 4 years, but he is now back. 2025, Sunil is back as president designate. This is quite exceptional and testifies the acknowledgement and recognition for Sunil as a great accomplisher and a great leader. You see here Sunil Gupta in the General Assembly in Haikou City in China. This was in October last year. So I will finish by telling you that IUPAP is proud and happy to have Sunil leadership on the organization. Sunil, really, you are a great scientist and great personality. I wish you all the success in your new position. You started already very strongly with the organization of a one-day, very visible IUPAP CERN symposium within the 39th ICRC on July 19th with NASA astronauts, and the theme that we will develop during this one day will be space and society. Thank you very much, Sunil, for what you did for IUPAP. Thank you and good luck for your new adventure. I am sure that you will do a great job. Thank you. I stop the sharing. Thank you very much.
Thank you so much, Professor Spiro. I understand astronaut Luca Pamitano has joined, so it is my pleasure to invite him to deliver this speech. Colonel Luca Pamitano is an active astronaut. He spent more than 1 year in International Space Station, performing spacewalks 6 times, spending 33 hours. He was decorated with the second highest military award by the Italian president. He was responsible for replacing the cooling system for AMS, alpha magnetic spectrometer, during spacewalk. Colonel Luca Pamitano.
Good morning, everyone. Actually, good morning from Texas. Good evening in India. Thank you for having me. Can everybody hear me? First of all.
Yes, loud and clear. We can hear you.
Thank you. I apologize. I understand I might be late. I'm currently in a different location. I am in Wichita Falls, Texas, getting ready to fly with the Italian Air Force, which is my armed force. And so I was getting ready for different events. I'm really excited to be able to join remotely. I wish I could be there in person. to say congratulations to my good friend Sunil. We only met recently, but we have a little bit of history thanks to the AMS. You have to know that during my second space flight, I performed 4 spacewalks where I was leading the efforts to repair the AMS. If you don't know what the AMS is, the alpha magnetic spectrometer is one of the most important experiments of astrophysics on the space station, probably the most important experiments of astrophysics on the space station, where it is currently still capturing charged particles, some of the oldest charged particles wandering in the universe. I am not an astrophysicist myself, so I don't want to make a fool of myself, but thanks to Sunil and Professor King, I have come to understand the importance of the alpha magnetic spectrometer in the way that it is revolutionizing our understanding of the universe, how it's made, where it came from, and where it's going. And also, it's telling us stories about us, where we come from and what we are made of. About 6 months ago, Sunil and I were having a conversation about the alpha magnetic spectrometer, and he gave me his own personal view of what makes the alpha magnetic spectrometer AMS-02 such an incredible instrument. He was explaining to me in very simple layman terms that if the universe is a machine and we want to understand how it works, we have to look at it. And when we look at it using normal telescopes, for example, the Hubble Space Telescope or the James Webb Space Telescope, what we get is information through photons, just the photons, particles of light that travel through the universe in a straight line at the speed of light, and they don't collect any information, but they give us beautiful, beautiful images, as opposed to the 35 types of charged particles that AMS collects. AMS doesn't take glamorous pictures, and so it may never become as famous as the James Webb Telescope or the Hubble, but it gives us an understanding of what the engine is. And so Sunil compared the photons and the images that we take from the telescopes to the smoke that comes out of an engine, while the charged particles that AMS is able to capture and define for us are the machinery inside the engine. So nowadays, we are still not capable of really understanding how the machine works, but at least we see the gearing, we see how it works, we see the machinery, and we can try to understand how that works. I've been using that explanation by Sunil for the past 6 months every time I talk about my spacewalk, every time I talk about the AMS. And it is one of the best analogies I've ever found. And all the people that hear this analogy, they get a very quick understanding. They love the analogy, and they support all the effort that we made to fix the AMS and the ones that we will make in the future, hopefully to upgrade it to make it even a better machine. So it's been a pleasure and an honor getting to meet Sunil. I want to wish him the absolute best of luck for the next tenure, and I am sure that with his posture, with his wonderful personality, with his warm embrace of both science and humanity, he will be able to deliver a fantastic job. And it is really, really, really an honor to be here and be able to say hello to you and wish the best of luck for the next years to Sunil.
Thank you very much, Colonel Parmigiano. So we move on. It's my pleasure to invite Professor Jayanendra Jain. Professor Jain is Evan Cook University Professor and Alvin W. Mueller Professor in Physics and holder of Eberly Family Chair in the Department of Physics, Penn State University, a world-renowned condensed matter theorist who has made seminal contributions in strongly correlated systems, topological phases of matter, fractional quantum Hall effect, and exotic emergent particles like composite fermions, anions, and Majorana particles. Some of the most notable amongst his numerous accolades include the Oliver E. Buckley Prize of the American Physical Society in 2002, and very recently the Wolf Prize in 2025. Professor Jain.
Hi, am I audible?
Sure.
Okay. So it's truly a pleasure and an honor to join this very eminent group of speakers today to congratulate Sunil Gupta for being selected as the president designate of IUPAP. I was looking at the list of past presidents, and it includes eminent names such as William Bragg, who was actually the founder of the organization, Millikan, Siegban, Neville Mott, Burton Richter, and Homi Bhabha. Sunil is the second person from India to be chosen for this position, the first being Bhabha, who served as the president more than 60 years ago. So this is actually a proud moment, not only for Sunil and the Tata Institute of Fundamental Research, but for the Indian science as a whole. So I noticed that most of the speakers, at least the ones that I heard, were in the field of astroparticle physics. I'm in a different field. I'm a condensed matter theorist. My association with Sunil began in 2017. So I had been visiting the Indian Institute of Science in Bangalore during the summer, and when Sunil learned about this, he graciously arranged for me to visit the muon detection facility in Ooty, which I later learned was a product of Sunil's extraordinary vision and persistence, in collaboration with scientists from all around the world, but especially from Japan. So my visit to Ooty was brief, but it left a lasting impression for several reasons. First, of course, was the surroundings. So as we have seen pictures, or if you have been to Ooty, you would know how beautiful this place is. And the guest house of the cosmic ray facility where my wife and I stayed was located right inside the stunning botanical gardens. So that we really appreciated. The second thing was that, I'm a condensed matter theorist, and I'm more used to seeing tabletop experiments. So this actually is the only cosmic ray experimental facility that I have ever visited. And the sheer size and the scope of the experiment were both spectacular and awe-inspiring. The third thing that this filled me with pride to see that India is home to the most sensitive muon telescope in the world, with hundreds of scintillator detectors. So I could only imagine how much effort and how much leadership it must have taken to build the laboratory from ground up. So when we were leaving, the host asked me to write a few words in the visitor's diary. And I still remember that I wrote that this was a fantastic example of what we can build in India. So this was an allusion to the Make in India campaign that had been initiated by the Indian Prime Minister at that time. So since the first interaction, this first interaction has grown into a very deep and fulfilling friendship over the years. And with every encounter, my admiration for Sunil has grown, both as a scientist and as a human being. I have also had some relationship with IUPAP, although admittedly it's been quite peripheral. It's indeed a remarkable organization that has influenced the course of physics for more than a century. And during my career, I have attended many conferences which were supported by IUPAP. My closest encounter with IUPAP was in 2017 when I organized the conference called Electronic Properties of Two-Dimensional Systems at Penn State. This is the flagship conference in my field. And at that time, we benefited from IUPAP's very generous sponsorship. So because of their support, many young physicists from scientifically remote parts of the world could participate in the conference. They would not have been able to attend otherwise. So when I heard that Sunil had been chosen as president designate of IUPAP, my immediate reaction was, what a great choice. Over the years, I have come to know that Sunil genuinely cares. He's deeply passionate about the promotion of physics, about building international scientific collaborations, about integrity in physics, and about mentoring the next generation of physicists. So given that IUPAP's mission is not just to promote physics, but also to build international scientific collaborations, inclusivity, and excellence, it seems Sunil is just the right person to nurture and lead this organization into the future, and perhaps to even greater heights. I should add, and I don't know if this has already been stated by others, that Sunil's election to IUPAP's president designate is also significant in a symbolic sense. So when I was going over the list of past presidents, I noticed that with just a couple of exceptions, all of them were from either United States or Europe or Japan. Sunil's election is a recognition, I guess a powerful recognition, that physics is a truly global enterprise and science leadership can emerge from anywhere, including from India. So Sunil, it's my pleasure and honor to offer you my warmest congratulations and my very best wishes. I wish I could be there in person to congratulate you. And looking at the program, I'm especially sorry to miss the high tea in the Western canteen. Thank you.
Thank you so much, Professor Jain. The next speaker is Professor Barry Barish. Considering the extreme time difference between our two places, as organizers, we decided to place him lower down. But it is so very gratifying to note that Professor Barish joined right in the beginning when we started this program. So Professor Barish is currently Ronald and Maxine Linde Professor of Physics Emeritus in the Division of Physics, Mathematics, and Astronomy at Caltech, a world authority on the physics of gravitational waves. Professor Barish was awarded the Nobel Prize in Physics in 2017, along with Rainer Weiss and Kip Thorne for decisive contributions to the LIGO detector and the observation of gravitational waves. In 2023, Professor Barish was awarded the National Medal of Science by President Joe Biden in a White House ceremony. Professor Barish.
Thank you. I'm very happy to join this group today to congratulate Sunil Gupta on his election as president designate of the IUPAP. I'd like to start by adding a little bit to what Michel Spiro talked about. It's hard to add to Michel because he presented it very comprehensively, but IUPAP itself, so the job that Sunil's taking on. IUPAP, well, first I had a connection to IUPAP directly as chair of one of the commissions, Commission C11, which was the Commission on Particles and Fields, my old subject, in 2010. And we were grappling at that time with problems of the changes of physics and how a long time organization deals with that. In particular, the field of particle astrophysics, which was emerging, and we brought in as a kind of associate commission, part of C11 at that time, because it didn't have a home. I'm gratified to see that not only has it developed a home, but a home in a flexible way that one of the oldest commissions, C4, which is Sunil's commission, has adopted a new name and adopted that field, which is a vital part now of our research in particles and fields, in looking at the interfaces with astronomy and dark matter and all the areas that are adjacent to what we once did traditionally. As Michelle said, IUPAP is 100 years old. It's the most important and highest worldwide international non-government organization representing physics. So it is our organization to represent our subject around the world. We easily say, and I think it's mostly true, that physics has no borders. Countries have borders, governments have borders, but physics doesn't have any borders unless we put borders there. And many of the questions that Michelle talked about and that we deal with are how to ensure and how to enhance physics as we perform it now to make it more worldwide. For example, how to include the global South in a more inclusive way, how to include non-whites in a more inclusive way, and so forth. IUPAP, when it began, had 13 countries. Now it's something like 80, or 60, I guess. And so Sunil is taking over the presidency of a very wide, worldwide, a vast organization. It has a bunch of tasks, and I want to just highlight a couple. It, of course, assists in the worldwide development of physics and promoting physics as an essential tool for the development and sustainability. We heard this mentioned. We just had a special emphasis in Michelle's time of promoting sustainability. One of the biggest problems we have as human beings in the world as we become more modern, and physics has to play a role. It's not our research as much as our role as knowledgeable, scientifically oriented people. And now we have the fact that quantum physics is developing and playing such a large role as another focus point. Physics education, this is of course very important, and who else is going to worry about how we develop physics education around the world if it isn't IUPAP? Diversity was mentioned earlier, and of course, to be as good as we can be worldwide as human beings in physics, we have to be inclusive. We want to have the free circulation of scientists a continuing problem. We even have it today, and exchange and open exchange of data, which also is an ongoing problem. So there's other parts which Michelle talked about, but I wanted to highlight these few. I personally congratulate Sunil and look forward to the fact that he can take on these problems, first as designate president, then as president, so we'll have him for some time. He's obviously, as we've heard today, exceptionally well qualified. He has been in a worldwide important institution for years, the Tata Institute, so he's familiar with the way we perform physics at the highest levels. He's led a major technical activity, scientific activity, the Grade 3, which we heard about from several speakers. And he's technically developed high quality plastic scintillators, for example, proportional tubes and signal processing and all the equipment that we use centrally to perform much of cosmic ray physics, and not just cosmic ray physics, but often in particle physics, particle astrophysics, and so forth. He's also been a leader in training students. One of our biggest duties as a scientist is to propagate the field by having well-educated and the most talented young people be able to go into our field. And he's done broad contributions on solar storms, thunderstorms, and so forth. As president-elect, I'm sure he'll fulfill the roles that we've heard about today. He's told me that he is particularly interested in two things that I think are very important. One is to develop the global South, and that is to bring the rest of the world, the Southern Hemisphere, into the fold in a much stronger way than we are now. Since he'll be in for 3 years and then 3 more, I suspect we'll see a real difference in the next 6 years. And beyond that, I'd like to just mention conferences. One thing that IUPAP does is sponsor the largest conferences. In my previous field in particle physics, it has sponsored the biggest conference in the field every 2 years. And sponsoring maybe just sounds like an administrative job, but IUPAP has taken the role of making sure that in order to be an IUPAP-sponsored conference, the speakers, the attendees, and the conference has to be done in a way that spreads the participation, not just in attendance, but in speakers and so forth around the world. And so IUPAP is important to all of us. It's going to be in very good hands. And I congratulate you, Sunil. Thank you.
Thank you so much, Professor Barish, for your very insightful words. The next speaker, I call upon Professor Shivaji Raha. He is a longtime friend and collaborator of Sunil. He is somewhat closer. He's from the city of Calcutta. Professor Raha is a very distinguished and accomplished theoretical physicist. He did his thesis with John Archibald Wheeler. His specializations are in mathematical physics, elementary particle physics, hadron physics, and astrophysics. He has also been contributing in research of history of science. He served as the director of Bose Institute in Kolkata for several years. Professor Raha.
Thank you, Indranil. And it's a real great pleasure for me to be able to congratulate Sunil, but at the same time, I think I would congratulate IUPAP for finding a very, very able and dedicated leader as their president-elect and then president. I have known Sunil for close to 40 years, but our proper interaction started only about 22 years ago. And since then, it has been very, very intimate. We have been collaborators, but even more than that, we have been very good friends, family friends. And during this period, I have grown to admire Sunil for many, many reasons, and this admiration keeps on growing. Familiarity does not breed contempt here. The more I get to know Sunil, the more I get to appreciate his many qualities, the more I admire him. Not only as a scientist, a very capable and intelligent, dedicated scientist, his characteristics which have impressed me very much and served as my own ideal are his commitment to educating and interacting with the younger generations. Sunil and I jointly organized a regular school of summer school, alternating between Ooty and Darjeeling for about 10 years. And during those events, I have been deeply impressed by Sunil's meticulous organization, his propensity to go out and look for interested young people and bring them in complete respect, not ever putting anybody down. No matter how busy Sunil is at any moment, and he is often extremely busy, the amount of workload he carries is amazing. But I do not know of any single event when Sunil was brusque or hurried or brushed anybody off. He always had a smile for whosoever came to him and asked a question, however trivial or irrelevant it is. I've never seen him lose temper. And especially with young colleagues, he's always most encouraging and generous. Sunil's time management is really admirable. His grasp of physics, I need not elaborate. Anybody who has interacted with him knows how quickly he appreciates physics points and goes to the center of it. But Sunil's real contribution to scientific organization, especially in a place like India, has been in keeping faith in himself and his team and egging them on to raise the benchmark higher by notches every time. The plastic scintillators, which he started building in Uti, have also served as the basis of several of our passive cosmic ray experiments. And they are available to, he has been able to provide lots of Indian groups with them. And they are technically, qualitatively, and no way inferior to the most expensive substances that one can buy from abroad. And Sunil's great enthusiasm for broadening his horizon and taking everybody along with him are beacons of beacons for future generations. I do not know where to stop or how to stop, but I reiterate that I have learned more things from Sunil than probably anybody else. And I keep learning how to not only do physics, but also how to organize physics from Sunil. So I come back to the statement I started from with, that congratulations are due to Sunil, but congratulations are also due to IUPAP for recognizing a true leader and leaving the helms of this extremely important organization in Sunil's most capable hands. Keep it up, Sunil.
Thank you so much, Professor Raha. It is now my pleasure to call upon Professor Mayank Vaya, our former colleague and long friend. He will be speaking on behalf of TIFR Alumni Association. Professor Vaya.
Yes. So a lot has been said about Sunil's achievements as an academic, his achievements as an administrator, and as a personality. So I don't want to spend time taking much more to repeating those things. I just want to say that Sunil, we are very, very proud of what you have achieved as president, as a recognition as president of the IUPAP. And I'm sure from what we have known about you in the past, you will be a great leader, provide a lot of leadership and increase IUPAP interaction with Indian physicists, which will benefit both the international community and India. So on behalf of the TIFR Alumni Association, we are very proud and we are happy about your new recognition and your new responsibilities that you're taking. And of course, we wish you best of luck. And please let us know if there is anything you would like us to do to help you meet these aims. Thank you very much.
Thank you so much, Professor Bhaiya. The Sunil was supposed to be the last speaker of the day. However, we still have Professor Samting to address us, but Professor Samting will be joining late. He is here to join. So may I just request Sunil to say a few words?
Yeah. Put it here. Okay, so I have put a title, Journey of an Ordinary Physicist in a Great Institute Among Truly Gifted Colleagues. I joined TIFR in 1976. And what surprised me was that people here always seem to disagree with each other. They will be always arguing, debating, discussing. But one thing they all agreed on is how great our founder was, that he had great vision. He identified talented youngsters who could become, great physicists, great scientific leaders, and so on and so forth. So I realized that if I want to do something, I knew I didn't have the talent and I had no vision. So what I could do was work with people who are more talented than me. So that was my first principle. Always work with people who are better than me. And that was my first principle. And the second principle was, I didn't know what vision meant, though everybody talked about it. So I said, for me, vision meant long-term thinking. So I will not work on a project which was already ongoing. I'll work on something which is about to start. Worked at ground level, make the detector, make the instrument, perform the experiment, collect data, analyze data, publish result. So that was my understanding of vision. So those two things I followed, and then okay. So as I said, the work began in 1976, and the first task I was given was to test this gear system, which could, where the mirrors were mounted to track a specific star in the sky, in this case, a pulsar. And we found there were problems, that it was sometimes tracking too fast or too slow. And after 2 months of investigation, I figured out it is the mass distribution of the object which was changing, and it was becoming unbalanced, and that was twisting the shaft, which was 2.5 centimeter diameter. Once the problem was known, the solution was very easy to make. But that gave me immense satisfaction that even though it appeared to be such a trivial problem, it was very satisfying that we could actually solve the real problem. But then this experiment was being done in Rajvan, which was not the best place for making optical quality observation because there were city lights interfering. So we moved to Radio Astronomy Center, which was in that time in complete wilderness. So this was 44 years back. So the first task I was given was, go ahead and construct a building, because you need a place to set up your instruments and set up your detectors, control room and all that. So a 60 square meter building was to be built. Now, those were the days of controls of all kinds. So you had to get permit for getting cement. And when I joined, Professor Srikantan was the director, and we had a jeep, and there was no driver. So Professor Srikantan, in a very practical way, asked, does anybody know driving? So I raised my hand. Here is my classmate who is sitting there, who started driving at the age of 10. So I started driving at the age of 12 and got a license at the age of 18. So I had a valid license, some experience and so on. And Professor Srikantan allowed. So it was, I think, good move, because I was available for morning shift, evening shift, and night shift. The driving was not much, but it made it very handy. So when this construction started, my job was to, because this was in 10 kilometers from town, so labor had to be brought. So I used to transport laborers from, gather them in town, bring them over. Sometimes they'll run out of materials to transport construction material. So that became actually a goods carrier. And it took 6 months, but I learned a lot in the process. We had some
civil engineers who were supervising who used to come occasionally. So I became de facto civil supervisor. And this building is, this picture was taken by, I think, Ramesh last year. After 44 years, it's still standing with some sprucing up, it can still be used. The net upshot was I got my thesis. So I was very happy about it. Then I went on study leave, worked at Fermilab for 2 years, and then sometimes another place, and then came back. This was at the newly constructed Tevatron in Fermilab. And again, I worked on building this forward hadron colorimeter, which gave some useful data. And then in my second stint, I worked on a magnetic spectrometer. Now, when Professor Ting joins, he'll tell us about a real big giant magnetic spectrometer, that is AMS. This was a small one, but it was flown on a balloon at a height of 40 kilometers above sea level. And this is the team of people I worked. It was, again, a very fantastic learning experience. Now, coming back to India, we started Grade 3 experiment in 1993. And of course, where do we go? Rajbhavan was already too small. So we go to Radio Astronomy Center. And there was Professor Govind Swarup. This is a, almost 100-acre campus, 400,000 square meter. And Professor Swarup knew every square meter of that area, what the terrain was, how it is. And he told us, you go and work on the north side, because that way you'll cause minimum radio disturbance to radio measurements. And so we did that. In addition to that, he, as you know, Dr. Kapurkar knows him very well. He was a constant generator of ideas and solutions. And it greatly benefited my interaction. Now, unique thing about this picture is everything you see in the picture, with the exception of the Tata bus, was built by the members of the team, including buildings, detectors, you name it. So scintillator, proportional counter, I don't want to repeat it, even including computer cluster, which was built by Hariharan, who's sitting back there. So this is the, actually scintillator we made for our colleagues in reactor project group and for PRC. It's 1 meter long and it's sufficiently transparent that you can put a newspaper at the other end and see, and you should be able to read without any distortion. And this is the work on proportional counter, it has been mentioned, I won't go into detail. But what was unique about it is Ramesh, who is standing right there, developed really low noise electronics that it was virtually background field. The signal from U1, which you see this peak, and the small peak, which I have written KL5, the KL5 emission from iron, which is what the tube is made up of. So this has what has made the this instrument really the most sensitive. And when I say sensitivity, I should give an example. So as you all know that atmospheric pressure reduces as you go to higher elevations. The atmospheric pressure near my chin is a little bit higher near the top of my chin, about 20 centimeters. And that causes 1 sigma change in the muon intensity, which can be detected. Similarly, it's a very sensitive probe of atmospheric temperature in the upper atmosphere where muons are produced. You can detect changes as small as 0.06 degrees. And of course, it's a phenomenal detector to measure variation in interplanetary magnetic field at the level of 0.1 nanotesla. That's the accuracy with which satellites measure the interplanetary magnetic field. And there are 2 more things. It also can be used as a very effective voltmeter to measure voltage that develops across a thunderstorm, which we used subsequently, which again came about in a serendipitous manner. We were not planning to look for it. We found a phenomenon, and when we tried to understand, we found that it's caused by gigavolt potential. And then if you think of it for my friends like Arun, who works on a tabletop experiment, or Prabhu, we measure cosmic ray current at the level of 1 femtoampere with a precision of 1 attoampere. Most of the time you set up experiment to measure a specific phenomena, but sometimes you find something that's unexpected, a surprise, and those are actually fascinating. Many of speakers have mentioned, so I will not spend time on it. The weakening of Earth's magnetic field and the detection of 1 gigavolt potential in thunderstorm, which was predicted almost a century back, but there was no right instrument available to measure it. The previous best measurement was 100 megavolt. Now cosmic ray muons is the ideal probe to measure those kind of things. And of course, both these things are important because one has impact on the operation of electric grids and communication satellite. And the second one, of course, we all know thunderstorms are the leading natural phenomena that causes loss of life everywhere in the world, including in our country. Nearly 2,000 people die every monsoon season. So these results receive a lot of attention.
So this is something you all know. So I will come to my post retirement phase. And this is a picture of my colleagues who are standing there in the center is Professor Yoshi, who is the Chancellor of Chubu University. So he appointed me as a visiting professor. So I keep going there once a year, except during pandemic, it had to stop. And when we go there, we work together. Professor Kakami mentioned, he also is sitting somewhere there. And we work together, we eat together, and we spend from morning till night. And in between, we do our data analysis, discussions, and so on, write papers. And this is to a visit where they have a Muon telescope. You can see Mount Fuji in the background. And this is something I'm very proud of, Professor Kajita mentioned. This was the Memorandum of Cooperation, which came again about in a very interesting manner. Professor Kajita was invited by our Indian ambassador to Japan. And he was encouraging him to set up greater India-Japan collaboration. And Professor Kajita told him, do you know there's already existing India-Japan collaboration? And my Japanese colleagues are working, and my Indian friend is involved in that. He said, no, I don't know. He said, okay, this is his name and this is his email address. So I get a message from Indian embassy that during your next visit to Japan, please come and meet them. Ambassador was none other than Mr. Sanjay Kumar Verma, who subsequently became ambassador to Canada and had to be recalled under the Trudeau regime in certain special circumstances. So when I met Mr. Verma, it turned out he was himself a former physicist. He was about 10 years behind me and studied in the same in IIT Delhi. So he knew physics, and he was very impressed that we have such a long collaboration. We have some. He said, we should sign a memorandum of cooperation. What do I need to do? I said, well, we have a process, TIFR will be involved in the post Department of Atomic Energy. Okay, so I'll call the chairman. So he called Mr. Vyas right in front of me, and Mr. Vyas, of course, knew me. So he said, yes, I know him. We'll be very happy to support. And he said that, it is the policy of Japanese government and Indian government to foster stronger collaboration. So we should do. And then, of course, paperwork began, and paperwork always takes a lot of time. Then Ramki became director, and things just speeded up. And finally, we had agreement signed on March 31st by the two directors. And as Professor Kajita mentioned, this is the last official document he signed before he stepped down as director. And then my interaction, I have known Professor Samping for almost 3 decades. And he was asking me to come and visit there, but then pandemic meant I could not go there. So I finally visited in 2023. And this man is absolutely remarkable. In this picture, he's 87 years old. So he invited me over for lunch. We had lunch, and then he said, let's go to the lab. So he drove to the lab on Sunday afternoon, and we had an interesting meeting. This is a visit to the control center of AMS, where they keep track of the space station 24/7. They cannot allow the instrument to fail even for a few minutes, because then the certain systems will freeze over and the instrument will be dead. So they have to be active all the time. These are the 2 people who are in charge of controlling. So during this visit, I made some suggestions which Professor Ting accepted, to have a workshop where all the unpublished data will be shared. So somehow he has a reputation of being a tough guy, which is not true. He is a very methodical person. And so we had a half-a-day workshop in Nagoya, where the next ICRC was held, and nearly 70 experts participated. And now, different groups are looking at what are the things we can do. So basically, they have so many results, unprecedented results with unprecedented precision, that every paper of Professor Ting concludes with the comment that this is our measurement and there is no explanation. Well, there is no explanation, because theories were developed to explain data which had error bars of 100%, and now he has 1% precision. So it's not possible to explain. So this is something which was very satisfying. And this is the time I also was awarded the Kelly Medal. And this picture, we have, Professor Ting, Professor Kajita, Mrs. Ting. And in the center, on the shorter person is Professor Sugiyama, who's the president of Nagoya University. In the evening, he took us out for dinner. And in deference to my vegetarian constraint, was a tofu restaurant. And last year, Professor Ting invited me to, Houston Johnson Space Center for the critical design review of AMS upgrade. So this is a 7.5 ton instrument. I think we'll have time to talk about it. And it's going to undergo an upgrade, which will add another 1 ton to its weight. So it'll have 2 SpaceX rockets, which will have to carry. And astronauts like Luca Parmitano, he had worked earlier also on AMS. So that is how I met there in Houston. And there were some dinners, etc. And here you can see, well, here you can see, huh? Oh, okay, so this is Luca Parmitano, and this is the guy who is responsible for mission control, and this lady is the one who trains astronauts. This selfie was taken by this guy, who is his name is Slavoj Uznansky. He is one of the astronauts who will go up in Axiom 4 along with Shukla, Indian astronaut Shukla. We had invited Shukla also, but he could not join because his family was there. He was visiting. These are all NASA engineers. So I had very interesting interaction with them, and I found these guys are, of course, have a very different perspective on things. So it was quite interesting. Then, I went for General Assembly last year. So when I was about to go, Professor Ting called. He said there is going to be a workshop to commemorate the 50 years of discovery of J particle in Beijing. He said, you'll be in China. Why don't you come there also? So I said, what will I do? He said, you give a talk. I said, who are the others? And he said, okay, I'll be speaking. Sheldon Blashow, David Prof, and Luciano Miami. And I was shocked because these are all architects of standard model. And I have zero contributions. I said, don't you think I am the complete outsider? I have no knowledge of anything. Immediately he replied, that's why I wanted to come. So I was in real soup, what to say in front of all these great stalwarts. I cannot add anything of value to the discourse. So I was scratching my head. Then it thought occurred to me, I should wear my IUPAP hat. And I started thinking, what is the role of IUPAP? Okay, it is to foster international collaboration. What has Professor Ting done in 60 years of his career? Fostered the largest collaboration. He had, during Cold War, scientists from Soviet Union and United States working with him, from China and Taiwan working in the collaboration, India and Pakistan. And even till today, people from all these places work together without any problem. He doesn't care about politics. He has trained thousands of students who have become leaders in their own right, in different places. This guy is the director of Institute of Analytical Physics. He's a former student of his. This is another of his students. He's another of his students. So all these people have been trained by him. And so I basically highlighted his role in training of these people and so on, how he has influenced the growth of physics in parts of the world where it was not particularly strong. Of course, TIFR is no exception. Our colleagues in experimental high energy physics group in TIFR, in Punjab University, in Delhi University, many of them who have worked on L3 experiment have been trained by Professor Ting. And then on his fair day, they gave us a tour of the Forbidden City Museum, where they are restoring the ancient artwork of Qing and Ming dynasties. Okay, so since the time is short, I will not dwell on it. We have already heard about it, that IUPAP has a 100-plus-year-old history. And first, it was presided over by William Bragg, succeeded by Robert Millikan, and of course, Dr. Bhabha was there. But one of the things that I particularly feel strong about is this statement. You see, whenever some war happens or conflict happens, some countries try to stop people from one country to attend the conference in another country. So this statement was issued IUPAC during the darkest days of Cold War, apartheid, and many other difficult political era of past 100 years, has always been able to do two things with care and responsibility. Keep the doors, channels of community scientific cooperation open, and of course, while expressing concerns about these things, it would be totally inappropriate to bar participation of any scientist from anywhere So in the recent case, there is no reason to bar Russian scientists from attending any of the conferences, as long as they adhere to the ideals of IUPAP. So this is something I think which is very unique about it, and I feel very privileged that to be part of such an organization. I have a very long, even 10 years of association with C4. Before that, I served 3 years as an associate member. And we used to meet every year. This was a picture taken in Vilnius, Lithuania. And then I get to interact with, actually, they have commissions up to C1 to C20, but there are no C7. So there are only 19 commissions, out of which one of them is C1, which is deals with finance. So there are actually only 18 commissions of the which. And since I was chairing C4, so there are 17 other commission chairs that I could interact with. That was really nice because this was a priceless opportunity to learn from them. I knew nothing about those areas. And again, I found they were all more talented than I was. So I benefited from my interactions with them. And this was during a meeting in London. And these two gentlemen were really influential, So the interaction with executive council, which is basically president and vice president, etc., was a great learning experience. Past president Bruce McKellar, he was awarded the Australia Order of Australia, which is the highest prize equivalent to Bharat Ratna by Australian government. And he is an encyclopedia of the rules, regulations, bylaws, just like our friend Arun Grover here. He knows everything about the history of IUPAP. So anytime I need doubt, I just call him and he will clear those. And then there is this infinitely resourceful, dynamic president designate at that time, then president and now past president Michel. Michel is again a very, very remarkable person. He just takes initiative after initiative and delivers on it. The idea of having International Year of Basic Sciences for Sustainable Development was his. He convinced United Nations and got a unanimous resolution passed. I asked him, how could you do that? They can't agree on anything. How did you do it? So please tell me how that diplomacy works. Then people kept talking about we should involve younger people. So he created Affiliated Commission 5, which is basically physics students, and Working Group 16, which interfaces with physicists working in industry. So these are all the initiatives of Michel Spiro. So he has been my guru. And in 2022, we have the centenary celebration. They asked me to chair the panel discussion on Asia Pacific region, which was a fun thing to do. And then on to 33rd General Assembly, which was in this beautiful city, Haikou, in an island in South China. And of course, these photographs I don't want to show. We had good time, and I had the honor of addressing the thing. And I think somebody mentioned, I think Michelle also mentioned this, and so did Subir, that I feel very strongly that all the talent resides primarily in global south. All the resources and experienced people are in global north, unless the two come together. So I reached out to many of them who have spoken today and said that, I would like you to contribute to this when we do these conferences. We hold a very large number of them in developing parts of the world. So you people have to make extra effort. Not to my surprise, almost all of them replied in the affirmative. Many of them, more than almost a dozen of them Nobel laureates. So one of the initiatives Michelle mentioned is, so I proposed to the organizer of the International ICRC, International Cosmic Ray Conference, which is being held in July this year in Geneva, that I would like to hold a one-day symposium where we'll have very, great speakers, which meant Nobel laureates. So we have, 3 of them you saw, or you will see, Varish, Vedita, Ting, and Michelle Nair, who is the discoverer of first experiment, as the speaker. And I reached out to them and tell them, please don't talk about the science. You tell how your discovery is going to be the society in the long term, or make the society in the long term. So talk in that term. And then this day, 19 July, happens to be the day when there was the first landing on the moon by Neil Armstrong and Bud Collins. So that's why we have many astronauts. And Luca Parmitano has become a friend. And then there are many others who we reached out and they have all agreed to participate. So we'll have a one-day event. And before Neil Armstrong put the American flag on the moon soil, he opened a a device which was basically a cosmic ray detector to detect, nuclei coming from the sun. And then when they returned, they folded it and brought it back. So that also will be on display. That was done by a Swiss physicist. So this is another interesting picture. And here's my old friend, vice friend Linda. So he told me, he said, oh, I'm representing Sweden. And then he said, okay, now I've been elected as the president, of the Royal Swedish Academy for Physics section. So he was the one who was responsible for the 2024 Nobel Prize, which was just announced 1 week before. Then I asked him, can you share some details of how exactly you guys decided? He said that you have to wait 50 years. Of course, he did share some private details, which I cannot talk in public. This is a very fond memory for me. Dr. Mohanty invited me twice on the occasion of World Hindi, Vishwa Hindi Divas on 10 January 2020 and 2022. And, I studied physics in Hindi up to PhD. So fortunately, I could still remember some of it and speak without using any English. Though they were generous, they said I could use some English. Before I conclude, I would like to highlight 3 of the stalwarts we have recently lost, Dr. Srinivasan, Dr. Kuren, and personally. I have personally benefited from their wisdom, guidance, friendship. And Professor Nalikar was also my teacher. It's a huge personal loss for everybody. Because Dr. Srinivasan lived in Uti, I used to, every time we held a workshop, I used to ask him to chair the organizing committee, which he used to graciously agree. Here are some snapshots from that. And Dr. Kasturi Rangan visited us for 3 days in 2017. As usual, I showed him all the detectors. And before leaving, he said, I want to share a story. You see, when I joined here, he said, I want you to make a professional company. He said, we don't know how to be in the library. And then, make something. It will not work. Try again. It will take some time, maybe 1 month. He said that 1 month became 2 years. But when I succeeded, I got the greatest satisfaction. He said after that, the Mangalyaan, Chandrayaan, and all other satellite projects, none of them have given me as much pleasure as the first proportional counter that I built. And then, of course, my great mentor, Professor Srikantan, who was a constant presence in my life, very inspirational figure. When time of stress, I would reach out to him. And there is Dr. Kakodkar, whom I have known for almost 25 years. The first meeting happened right in this hall. When Dr. Kakodkar, you came during planned discussion. And during tea break, I persuaded him to come to my lab on first floor. And to show rudimentary efforts in scintillator making. I didn't even have a chair to offer him. He was standing along with Dr. V.C. Sani, and we were talking for more than an hour. After that, I wanted to talk to him. I called his secretary. He gave me his phone number, personal phone. I said, is it all right for me to call his home? Those days, mobiles were not common. He said, yeah, you can call him. So I occasionally used to call Dr. Kakodkar. More than a decade after he stepped out, said, Dr. Kakodkar, why did you give me that number? He said, I think Dr. Kakodkar will definitely remember. You give unfiltered opinion. And that is valuable when you want to make decisions. You should not have too many filters in between. So I'm very grateful to Dr. Kakodkar. He has been a mentor to me, but he doesn't agree. He says, I'm your friend. So we have a disagreement there, going back 2 decades. These are 4 great friends of mine who has been a real pillar of support. Shivaji Raham, who just spoke. Naveen Singh is sitting there, a great mathematician, man of great conviction and ideas. And Tariq Aziz, I think he could not make it. And then, of course, Arun. Arun has been described by various terms. The one I like best is, I think Professor Vijay Raghavan called him force of nature. He is a force of nature, which nothing can stop. The amount of drive, energy is just infectious. So I'm really grateful to these people for being. And I'm really profoundly grateful to the non-academic staff in the Institute for their contributions, which were critical in the success of every endeavor of mine. That includes scientific engineering, technical, administrative, and auxiliary staff. Because I've never seen an institute where everything worked with clockwork precision as it does in TIFR. We are really privileged to have these people. And finally, I would be amiss if I did not mention my wife, Nupur. She has been bedrock of support. And keeping with my, philosophy, she's better than me in everything, possibly with the exception of physics. So she has taken care of the house. She has been a full-time school teacher, and I could not have done without her. She literally raised our 2 children, who have now grown up into adults. This is my son with his family, his daughter with her family, both of us with our 3 grandchildren, the entire family. And before I stop, I would like to thank Jairam and Indranil, etc., for putting together this event. I didn't deserve it, but I'm grateful. Thank you very much.
Thank you so much, Sunil, for taking us through this 25 minutes abridged version of your fascinating 40 years of journey. And you told us with all humility that you learned driving at the age of 12. I'm sure you had not initiated yourself in cosmic ray physics at that time. It took another 10 years. But after that, we can say with a degree of conviction that for the last 3 decades, you have been at the driver's seat as far Indian efforts in cosmic ray physics is concerned. And you have kept our beloved GREPS facility in the UT alive and kicking. Thank you so much for all that. So now we come at the end of the function. The last speaker of the day is Professor Sam Ting. He has joined us. So it is now my pleasure extraordinary to invite Professor Sam Ting to deliver his speech. He is currently Thomas Dudley Cabot Professor of Physics at MIT. He has been there since 1969. Professor Ting received the Nobel Prize in Physics in 1976 with Barton Richter for their pioneering work in the discovery of the Gibbs-I particle. An indefatigable experimentalist who works with a missionary zeal at the forefront of elementary particle physics, astroparticle physics, and state-of-the-art instrumentation. He proposed, constructed, and leads the Alpha Magnetic Spectrometer AMS experiment on the International Space Station, involving 500 scientists from 16 countries, searching for the existence of antimatter and the properties of cosmic rays. Professor Sam Ting.
Yes, thank you, Mr. Chairman. It's an honor for me to be here together with you to celebrate Sunil Gupta's ascension to the IUPAP president. For my wife and I, it has been a privilege for us to know Sunil Gupta. So, Gupta leads the great 3 cosmic ray experiment for decades and to transform it into a major international collaboration in the field of atmospheric, solar heliospheric, and galactic cosmic rays. And the red points are the Graves measurement compared with the different measurements. 2 of the results published in Physical Review Letters on solar storms and thunderstorms has fundamentally advanced understanding of this phenomena and attract global attention. I consider the development of high-quality instrumentation in India is its most important scientific contribution because the quality of physics depends on sensitivity and reliability of the instrumentation. I admire the fact that Professor Gupta has always focused on one experiment at a time. He led the IUPAP Commission C4 with distinction. Let me share with you a history of Sunil Gupta and AMS. I regularly discuss AMS results with Sunil as I value his insight. In the spring of 2023, I invited Sunil to AMS general meeting at CERN. His advice was helpful in preparing for International Cosmic Ray Conference in Nagoya later that year. During the MS meeting, I introduced Sunil to the visiting NASA management. In September 2024, I invited Sunil to Johnson Space Center in Houston to attend the critical design review of MS upgrade. Sunil communicated to NASA engineers and astronauts in simple language and importance of MS upgrade. In this meeting, Sunil has obtained the highest respect from NASA. In October 2024, the Director General of the Institute of High Energy Physics in Beijing, Yifang Wang, fellow of the Royal Society, invited Sunil to attend international conference to commemorate 50 years discovered since the November Revolution in physics. Together with Sheldon Glashow, David Gross, Luciano Mayani, and myself. Afterward, Sunil developed an eloquent summary on the development of modern physics to the conference. Well, high-energy physics has advanced rapidly in China. The Shandong Institute for Advanced Technology in China was recently established in Zhejiang province. Sunil visited them in April this year and made excellent suggestions for its future growth. I'm confident Sunil will have a successful IUPAP presidency over the next 9 years in the tradition of Baba. Congratulations. Thank you.
Duty to propose a vote of thanks. I would like to express gratitude to all the distinguished speakers who have made time out of their busy schedules to join us in person or online and share the invaluable insights with us. In particular, I would like to thank 3 of our preeminent overseas speakers, Professor Samuel Ting, Professor Barry Barish, and Professor Takaki Kajita, who have defied the constraints of space and time to thrill us with their wonderful speeches. I would also like to thank each and every one of the participants in this meeting who have joined in person and online. I especially thank the alumni of TIFR for their participation. This meeting would not have been possible without the advice and active participation of our director, Professor Jairam Chengalu, who has been with us at every stage in the planning for this evening. Thank you so much, Jairam. Special thanks also due to Professor S. Ramakrishnan and Professor Musansir Burma, our past directors, for their participation and speeches. For a program of this kind, there are several other players whose contributions are unseen but should not go unsung. Let me list some of them so that we can also thank them for their selfless efforts. The TIFR canteen staff for arranging the high tea after this event. Special thanks to Professor Rajdeep Sen Sharma, one of the organizers, and also the chair of canteen committee, and Sri Tambe in charge of the TIFR canteen. The auditorium staff have ensured that everything works smoothly and for ensuring that the remote talks and recordings could proceed without any hitch. The PRO section of TIFR, especially Sri Vinay Bhosle, who has worked to coordinate the visits of the dignitaries. The photography section of TIFR, as you will have surely noticed, have been keeping records of this happy occasion. The Parks and Garden section of the TIFR has provided all the nice floral decorations here as well as the bouquets presented. The TIFR security has been active to see that no breaches occurred and is still on duty as I speak. We, the organizers, express our sincere thanks to our young colleagues, Dr. Hariharan and Sri K. Ramesh for preparing the beautiful poster and the PPT presentation that you enjoyed on the screen that was running. Finally, though you have been seeing me here standing here and speaking to you, but I have really done the list of it. Three other gentlemen who actually worked very hard for it. Professor Amol Dige, please stand up. Our colleague, Parag Shah and Rajiv Sen Sharma. He has left for his vacation, but before that, he did all his part. Thank you so much to all of you. And that brings me to the end of my list. If I have failed to mention anyone, I apologize most humbly. For any omission was purely inadvertent. Thank you so much. Thank you. I also thank all of you who have joined over Zoom. We will now close the meeting and we'll head for the high tea to West Canteen. Thank you.